take it away.
Can you see, hopefully everyone can see our screen?
Yes, we have it. Yes, perfect.
Okay. I cannot see you, so if anyone has questions, please just give a shout.
Yes.
So our agenda for today is we'll just do a quick introduction of Ravi and me and the Search Lab. We'll set some context for what it is that we're trying to do and why. We'll say a little bit about what semantic search is and why we think it's a good solution for our needs. And we are approaching semantic search from multiple different angles. So we'll talk about our approaches and do a few demos. So I'm Erin Wise. I work in the library here at Harvard Business School. I'm the Associate Director of Information Management. And Ravi, if you want to introduce yourself.
I'm a Principal Software Engineer in HBS IT.
And the two of us are sort of the Search Lab. We're it. But the work that we're doing is a collaborative effort between Baker Library and HBS IT. We're the primary leads on this, but we have executive support and sponsorship, and we're also collaborating with the many subject matter experts that we have access to. And as I'm sure everyone is aware, we have 1,000 AI flowers blooming right now. So the entire world is kind of trying out various AI efforts, and we are one of them. We're just one effort in our corner of the business school. We like to think of ourselves as the most beautiful and fragrant flower of all the flowers that are blooming. And Ravi chose this nice image to illustrate how we see ourselves. So sorry, we're just coordinating between our two laptops here, so sorry for a little delay. So the context that we're working in is a few years ago, the business school published a digital transformation report. So there was a big effort by the school to assemble a task force and look at what we should be doing for digital transformation. And one of the results of that report was that we need to be able to efficiently and effectively find information and resources across the campus for all stakeholders. So that's been a pain point for the business school for a while, and we interpret that as the need for relevant search results across disparate content repositories, and we further interpret that as a need to understand the intent of user queries and the relationships among our source data. So why semantic search for this purpose? So semantic search allows us to understand meaning, not just literal keywords. For example, we can interpret queries. We can interpret the language of queries in order to surface relevant information, even when the exact query is not matched in the content results. We can connect related concepts, so we can use metadata to connect concepts in order to help surface relevant results. We can synthesize information instead of just surfacing links or raw matches. We can synthesize information based on the information structures that we've created and the content that we've very specifically described. So that reduces noise and increases the precision of the results that we serve. And it's also nice for non-experts, so people can just use natural language in their queries. They don't have to try to figure out what keywords would be most relevant to them. So we're coming at semantic search in multiple ways. So we interpret semantic search broadly as to mean search with meaning, and we can get at meaning in various ways. So lexical search is sort of the traditional approach, and we retrieve information by matching words and phrases in a query. So lexical search we have, that's in place. We have in the libraries particularly a lot of taxonomies and thesauri and vocabularies at our disposal. So we wanted to use an approach of what we're calling taxonomic semantics. So we're understanding queries based on the thesauri that we have that shows related concepts, parent-child concepts, and so forth. We also are interested in a graph rag approach. So we have a knowledge graph. The library created a knowledge graph a few years ago that models many of the kind of key assets of the Harvard Business School, publications being one of the primary ones. So we can leverage the graph to retrieve and relate connected content. Finally, we're using a vector semantics approach. So we are applying embedding models to give us probabilistic relationships among queries and content so that we can supply relevant results. So that's as opposed to the deterministic approach of taxonomies and graphs. And ultimately, we assume that the best scenario is going to be a hybrid approach. So it's going to be a mix of the various different approaches that we're testing right now. So our little timeline is we started, and Ravi will be demoing this later, we started with the taxonomic semantics approach. We did a little graph rag POC, and we're now working on our vector embeddings approach. And the questions that we're looking to answer in these various approaches are which are best suited to which use cases, and how can we best use our various data structures and information structures to achieve relevant search results. So the POCs, our approach is basically we're building POCs so that we can demonstrate to our leadership and our sponsors why these approaches are a good idea. And so basically we're just trying to illustrate the core functionality and potential of each of these approaches. We did not spend much time building them, and when I say we, I mean actually Ravi as the tech expert. I had nothing to do with it, but Ravi spent a few hours each building these, so it wasn't a huge time investment to actually develop these POCs. We have not yet fully tested them, so we're demonstrating the concepts, but we are not near production readiness, so that would be a follow-on step. But this year, we're looking to build the POCs and come up with a report and recommendation to give to our leadership, so that then we can decide how to prioritize putting things into production. Robustness work is still in progress, so some queries may not return expected results, so we're still tweaking and working with our subject matter experts to get at what ideal results would be. Our goal is to validate our direction and gather strategic input, and it's very helpful to have the opportunity to present to you today in order to help us do that. And I guess finally, we would just say that the proofs of concept demonstrate potential, and the production would require more effort. Sorry, hopefully there's noise outside the room, so hopefully you can't hear that too much. Okay, next slide. So the demos that we'll be showing today are taxonomic semantics, graph rag, and vector semantics. First up is our taxonomic semantics demo. So how this works is you can see on the left here on this slide that we took a portion of our taxonomy, which shows parent and child relationships as well as synonymous relationships among concepts. And the idea is that we can use the taxonomy to expand our queries. So on the right, we see this diagram that says we can input a query for trust, and we find a match at level 2 on the left there. So it's under psychology and behavior. We can walk up the hierarchy to psychology and behavior to find all the sibling concepts to trust, and take those relationships into account when we're serving search results. So I think Ravi, is it over to you now? Okay.
So this is how the query dispatch flow works. The takeaway from this slide is that whichever approach we take, whether lexical or using concept matching, using leveraging the taxonomy, we can use the same search index. There's no separate search index needed. So the query expansion engine does the expansion and sends off the appropriate query, which then will return results from the open search index, which is what we're using. And here we can flip to the demo. And before I do that, I just want to, just as a sanity check, because I cannot see your faces, I want to double check that there are no questions at this point. You're okay?
I will let you know, Ravi.
Okay, thank you.
We're all excited to see the demo.
Okay, so this is the demo here. And this is just to show you the taxonomy tree. It's on the left-hand side here. This is a topic hierarchy, and you can expand each one. And you can see it's a multi-level taxonomy. So without further ado, let's just try a query. And our favorite one nowadays is right here. And as you can see here, that I just need to expand this so I can see. I misspelled it. I'm sorry. We don't yet have spell check. Okay, so as you can see, this is just a plain lexical search. So here it matched on the keyword that was searched, remuneration, in our result. In our content that we're searching here, which is from one of our websites, which has several thousand documents, we got one result. But what if we did the taxonomic query expansion? That will give us an expanded result set by walking up and down the tree, as Erin described earlier. So here, the concepts that matched in that tree traversal were additional topic terms, really. And here you can see that the expanded concept matches returned 10 extra results. 20 extra results, actually. And these are actually the relevant results. They are not, because it matched on topic tags of that content. So what we might present to the user on an end user search results interface is a hybrid of A plus B, which is lexical and concept. So the user gets both, the benefit of both approaches. And finally, we wanted to show, if we walk further, if you do further tree traversal, we also get these related concepts. So these would not be part of the result set, but they may be an opportunity to present to users as you may be interested in. And by the way, we have screenshots of these also later on in the presentation that we can take a look at. In fact, and this is the exact screenshot of the search that I just did. Janis, you wanted to save questions to the end, right? Is that right?
No, I think we can just take a question. Shannon, do you want to start?
Yeah, sure. I was just curious about the order of these listings when you have the hybrid or the expanded, about the exact search result that came up with when you didn't have those extra combinations.
Mm-hmm.
why wouldn't that exact match come up as first, and then the sort of expanded results show up underneath it? Or am I misunderstanding how that works?
Right, that's a great question. So I would say, let me just hide the related ones for now so that we can just look at the expanded one. Yeah, so certainly we can play with the weightage of the lexical versus the concept. Here it's pretty much, I think, probably the concept matching is weighed a little bit more heavily. So depending on your use case, you might say boost lexical slightly over the concept matching. So we have that flexibility. Does it answer your question?
Sure, yeah, thank you.
And then I think in the chat, Seb had the same question, and Roland asked about the score. If you explain what the score is.
Yeah, so the score on the left-hand side for lexical search is it's the open search relevancy score based on the query that we're sending, based on boosts on title and so on and so forth. But the score in the expanded concept matches is right now it's just matching on the topic, and therefore you notice that the score is the same. So we can't really compare the scores across columns. We need to I think the scores within a column, a comparison might be more useful. But they're pretty close, as you can see here. So it starts at 62, but it goes down by not much in the first 10 results.
All right. I just want to be conscious of time. I know you have more to show us, Ravi.
Yeah. Okay, we can go on to the next one here. And over to you, Erin.
So our next approach is using a GraphRag approach. So we took a bit of the HBS knowledge graph. The library created a knowledge graph back in 2021 in order to relate very explicitly certain entities and concepts. We were getting a lot of questions about the relationships among things across repositories. So we decided that a graph would be a good idea in order to overlay and describe those relationships. So we modeled entities that are important to HBS. So faculty and publications are just two of them. Topics are another entity that we wanted to model, or concept that we wanted to model. And alumni stories are kind of news stories that the business school publishes that feature our alumni. So these are the four types of resources that we chose for this POC. And we can see in this diagram here just a very quick overview of how we're constructing the graph. So we're taking data about articles, faculty, topics, and alumni stories from various different repositories. We're cleaning and parsing that data and putting it into a node and relationship model. Excuse me. We're using Cypher scripts in order to generate a Neo4j knowledge graph. So that is what underlies the GraphRag functionality. So it's the basis of our queries and prompts. So graph augmented generation allows us to use natural language queries to retrieve structured results. And then the results are then inserted into the prompt, which give the LLM a very domain-specific, grounded context in order to produce responses to queries. So we're basically, with the graph, we've modeled what we know to be true about the various entities and resources at HBS. And so we feel very confident in the validity of those statements, and we're using it as a grounding for our GraphRag approach. And I think it's back to Ravi for a demo.
Take a look at the demo here. So this is the POC. So in order to save time, I'm just going to copy this question here. And we're going to try this query and send it off to this search interface. So just to describe what's going to happen here, it's going to go through this query to AnswerFlow, which is it takes the natural language query and then converts it into a Neo4j cipher query, which will be displayed on the screen, which is then sent off to the knowledge graph, which returns structured results, and then which are in turn sent off as contextual information to the LLM so that we can reduce the scope for hallucinations and we would get grounded answers. So let's just, without further ado, just see that in action. And we expose a lot of this in this user interface because it's a POC, but for a true end user interface, probably not all of this information will be displayed. So here you can see that the Neo4j cipher query is being generated on the fly. And then at the bottom here, we have a chatbot style response. We asked about what are the most common topics other than finance written by faculty in the finance unit. And the graph the graph returned some information which the LLM interpreted and gave the answer to the user's question.
All right. Thank you, Ravi. Any chance you could also jump to the AI summary that I think you showed us in person in Boston last month?
Oh, yeah, definitely.
Just so that we don't run out of time, because this is, I think, also coming up more and more.
Mm-hmm.
Like, hey, they don't want search results anymore. They want AI summaries.
Yeah. And just to give you the background for this one, this was done with the scope of a larger project outside of the search lab. So Erin and I worked with a larger team, and that was the implementation. But we're happy to show this to you. This is a beta for our internet search. And just to show you, so working knowledge is again one of our content buckets. So with the way this works is, let's just do intelligence as the query. And then we have this button here which says generate AI response. And this is what happens here is that the top 10 results are retrieved from our open search index, which is then sent off as, I'm going to kick this off because it might take a while, which is then sent off to the OpenAI APIs. And depending on how much time that takes to return, this might take a while. So maybe we can take a couple of questions here, Janos.
So Emma from Edinburgh had a question of what format was the knowledge graph in? Did this have to be converted to JSON or similar for the AI to make sense of it?
So we do convert it to JSON for the front end. Yes.
And then here, in the meantime, there was an AI summary.
Mm-hmm. Yeah, and to be right, and this is we are using a commercial product for this one. Actually, it's not developed independently. But here, what happens here is that the top 10 results are sent off to OpenAI, which then summarizes this, and we can also choose to add the citations, which we are going to do.
Mm-hmm.
As to, so it's not going off to the World Wide Web and generating the summary. It's generating it based on these results, which you may have seen in other user interfaces like DuckDuckGo or Google.
Be persuaded to share the commercial or the external product that you're using, open source or whatever it might be.
Oh yeah, it's a company called Swirl, SWIRL.
All right, I will leave it into the summary blog post.
Yeah.
We're at the end. I think we also saw the slides. We saw live demos. Any other questions, comments, reflections? Please feel free. Anything else from Erin and Ravi that you want to share in terms of what's around the corner?
So our goal is to work on our vector semantic POC, which we're doing right now with some of the librarians who have great subject matter expertise. And I wanted to just add to related to the AI summaries versus search results. For us, it really depends on the goal of what a user is trying to achieve. So AI summaries can be very useful in some contexts, and in other contexts, we're looking for more precision and kind of grounding in actual resources. So I just wanted to add that, and which is nice to it's what Ravi just showed. It's nice to have both, so one can choose one or the other.
Yes.
That's anything else you want to add?
That sums it up there. Thank you.
Thank you very much for sharing. We made it through. Really appreciate it. It's always, I think, a big privilege to get insights to the progress you're doing and to hear from kind of behind the scenes of your approach to making search better. I know that you worked on this for a long time, but it's really impressive to see the progress you made. And I think this kind of validates the opening statement of how search perhaps was stale a little bit for a long while, but now it's moving quickly, and expectations certainly keep going up.
Yeah.
Thank you. That's all we had, and we were able to make it right on time. So thank you, everybody who joined us. Thank you once again to Erin and Ravi for the open sharing. I really appreciate it.
Thank
very
you.
much.
Thank you.
Having us.
Bye-bye.
Thanks. Bye.
Thank you. Bye.